Go, go, go. Time to go. It's space time. Welcome to the superpilotish channel. My name is Graham Wilson, and today, in my nice, safe basement, I'm going to be talking to you all about the cool SpaceX Crew Dragon that just brought some people back the other day from up in the space station, and they made it back okay. So I was thinking about, well, as usual, what am I going to talk about today? And I thought I would enlist the help of Grok, the AI, good old Elon Musk. He seems to be everywhere these days, SpaceXing and Grokking and Xing and all kinds of stuff, Teslaing. So yeah, I thought I would go to Grok and get some information all about the Crew Dragon. So the Crew Dragon was the name of the ship that brought back the astronauts the other day. And I thought, well, at first I was thinking, how does that come back? I saw some pictures of the parachutes and stuff, and it's like, so I asked Grok. It's like the artificial intelligence version of, the artificial intelligence dude, whatever computer associated with X, formerly Twitter. And so Grok is like, it's pretty cool using that thing. It's some things it's better than others. For general technical stuff, it's pretty good. It saves you a lot of Google searching. It's kind of like an enhancement. It's basically kind of like Google searching the way it used to be before Google got all I don't know, before it sold out to the man or whatever. But it's pretty cool. So I was like, oh, I printed it out and I was like, oh, so that's how they work. But then and I'll be kind of talking eventually about the whole reentry process. I'm just giving you a little forward here. Then I thought, okay, there's that. Well, what about the heat shield? How does that work? And then I asked Grok, boom, and now it gives me all this information about the heat shield. And I thought, well, how does the whole reentry work anyways? And that's where we're going to get to here. Okay. And then even worse or better, I guess, like if I was in grade school or high school, I'd be all over Grok using this to write papers, man. It's amazing. So I was like, well, I researched all this stuff. I was getting ready to print it off. And then it was like, hey, why don't I just have Grok like write me a whole script for the show here and I just read it? So, hey, Grok, write me a 12-minute script I can read for my YouTube channel about re-entry of the Crew Dragon from SpaceX. Boom, prints it up. Like, I'm not going to do that because like Grok doesn't have my hat. It also doesn't have my whiteboard if I need it. So Grok, too bad, but it's pretty wild. If I was doing papers as a kid, man, boom, write me a paper on whatever, Romeo and Juliet. Here you go, teach. You probably failed the test, but I don't know. You get the papers in anyways. Okay, so here we go. Let's talk about our Crew Dragon. And there we go. There's the Crew Dragon. It's attached to the International Space Station. I just got this picture off of the interwebs, and you can kind of see there where how would I describe it? Okay, there's a bunch of like wires and tubes and stuff over on the right, and then there's a little flappy thing up there. That's where they kind of come in and out. And so it's the Crew Dragon is the little bit on the left, and on the right, that's the International Space Station. So right there, it's docked. And so what do we got to do here? So here's another cool thing. So that I didn't know. Have you ever heard of hypergolic engines? Let's do a little lesson on hypergolic engines. What is a hypergolic engine? How do you even spell that? So that's where Grok does not have a whiteboard. So here we go. Too bad. You're out of luck, Grok. How do you spell it? Grolic? I only heard about this today. It was what? I was just talking about. Okay. I thought I saw it on here. I don't want to spell it wrong. Oh, hypergolic. That's it. Hypergolic. It's not hyperbolic. It's hypergolic. Okay, what's a hypergolic engine? Okay. Oh, Daniel popped in here. So if you're watching this on your TV or something, this is actually live. And so Daniel popped in here and said the notification at his end is a little tardy. Yeah, that could. I don't know how the notifications work on YouTube and stuff like that. And I was like, maybe about a minute late starting, anyways. So we're talking about just for you, Daniel. Here we go. We're talking about this. We're talking about the Crew Dragon coming back in from the space station. Okay, now we're all caught up, and they're going to use hypergolic engines. So, what's a hypergolic engine? I didn't know until I found out today with Grok. And so, what that is so it's like the little engines. Let's see if we got this here. Let's show another little picture here just for fun. Okay, so that was on my thumbnail. So those were the crew members that came back from the space station, and you can see the Crew Dragon over on the left side of the picture. So around the Crew Dragon, the Crew Dragon, there's 18 of these little jets basically, and that uses it to move around up in orbit. And the hypergolic engine is I don't know exactly what it looks like exactly, but I was just reading about it. So what it is, from what I can tell, and I'm gonna make a little rocket engine here, and this is probably not what it looks like at all. Okay, and here we go. There's a little engine sitting on the side of the ship. So the hypergolic engine. Okay, you're gonna have two little nozzles in there. One nozzle here, one nozzle here, and that goes to a tank of fuel. Okay, here we go. How's this looking so far? We got our rocket nozzle, or these two little injectors here. Let's see if you can get the two little injectors coming from your fuel tank and your oxidizer, as they call it. So the fuel tank can be, this type of engine could be anything as long as it's got something that burns and something that's an oxidizer, which would be nitric oxide, pure oxygen, whatever you want. But the fuel that they use for the Crew Dragon, it doesn't have to be stored cryogenically. Like, it doesn't have to be really cold like those ones that see the ice coming off of the big boosters and that. A hypergolic engine just has like some type of. It's actually, I read up. It's a big long name. I'm not going to try to pronounce it or anything, but it's this like super toxic, carcinogenic, nasty stuff that you got to wear a spacesuit just to handle, and it's super explosive and stuff. Got to be really careful. And the oxidizer is some kind of, I don't know, something else. But the hypergolic engine, long story short, they inject some of this, inject some of that, and then it just instantly catches on fire. Okay, what's it look like? And then it starts shooting out thrust. There you go. So so the thing about the hypergolic engine that's pretty cool, it's very Elon Musk-ish, super pilot-ish, Elon Musk-esque, maybe Elon Musk-esque, is that so you don't need an ignition system there. So you just like put these two what would they be? Are they a liquid? I think, yeah. You just kind of stick these two things together, and boom, it just instantly ignites and gives you your thrust. So depending on how the Crew Dragon wants to move a little bit, you'll see like little things shooting off the side, and it'll just be like, okay, mix a bit more, little thrust, turn it off. Okay, shoot some more gas through there, or some more sort of fuel and oxidizer through. Boom, another little bit of thrust. So it's good for just kind of maneuvering and making the Crew Dragon position itself the way it's supposed to go, and it also burn a little bit, so it'll start burning. Like, get one of these things, but if you're upside down like that, and start shooting back towards the earth, and just kind of give it a boost. And then once it starts losing its altitude towards the earth, here's another thing I didn't know about, was that if you're coming into the atmosphere, I didn't know that the angle of attack was very like, I didn't know that was really that important to come back into the atmosphere. So I'll show you here. I'll give you a great picture of the world. We'll get rid of our hypergolic engine. There you go. Now you can be really smart at your dinner party and say, well, why do they? You can say, did you know that they use hypergolic engines on the Crew Dragon because they don't have to worry about an ignition source? because the fuel in the oxidizer just naturally ignite. I knew that. I didn't know that until just a couple, I don't know, an hour before the show here. But you can sound smart. So your angle of attack, here we go. We got the atmosphere. Okay, this is not to scale. That's the atmosphere of the Earth. We got the Earth over here. That looks like an eyeball or something. We'll draw a little North America. South America looks like an ice cream cone. You got Florida over here, coming up over there. Okay, that's North and South America right here. That's Florida right there. So anyways, if we're going to come into the atmosphere, it has to be at, we'll say it's coming right over the top here. And it's got to be 6 to 7 degrees. All right, so there we go. So if you got your spaceship coming in, and it's got to be between 6 and 7 degrees, you can see that, to get through the atmosphere and come back down into the Earth. Otherwise, if it's less than that, I didn't know it, but it'll just bounce right off, boing, like that. And then so you keep it at that, so it gets through the atmosphere. But if you're coming in too steep, if you come in too steep, then you're coming in too fast, and then you're going to be creating a lot more heat and a lot more friction, stuff like that. And you're like, I think that's probably why all the meteors and stuff just ignite on impact with the Earth, because they're not at 6 to 7 degrees to get through at a decent speed. So when it's coming in here, it's just like it's not counting on all of this area here to slow down. It's just going straight in, and then things going to blow up. So anyways, according to Grok, and it makes sense to me, you gotta have it between 6 and 7 degrees on the way in. Pretty cool. And I guess they figured that out over years and years. Oh, here we go. Too steep and it faces excessive heat and G-forces. Too shallow and it could skip off the atmosphere like a stone on water. Okay, yeah, and then so it tilts the heat when it's coming in. It tilts the little the heat shield on it to kind of navigate it. So that's pretty wild. And what else can I show you here? Okay, so you're coming down, and then so you're getting down slower and slower into the atmosphere, and all of a sudden you get a couple little parachutes pop out. So these are called drogue parachutes. So they're not the final like it's just there. The whole idea here is that you're slowing down. Whoop! I gotta do this a little better here. Okay, yeah, so you're taking all this time to slow down, so less G-forces like that. And yeah, so you'll also get, okay, now that it's slow enough and the air is really thin up here up top, so you're getting down a little bit more. Now your parachutes will work a little bit, so that'll keep slowing you down. So they have a couple drogue parachutes, what they call it. And I think they that one guy that tried to do that parachute jump from space with Red Bull, he had a drogue chute on there too. So it slows you down so you can get to the point where you deploy your main chutes. So let's do this. And so we do that. And then you get down to, I think they said 18,000 feet. Stabilization, parachute deployment. Okay. Yeah, so those chutes pop out about 18,000. Then once you get down to about 6,000 feet, then you got your big 4 parachutes pop out at 6,000 feet. And that'll, apparently, I was also looking into it. You can see there's 4 there, but apparently it'll work with 3 too. So they have 1 for redundancy. And they also have, yeah, so I think the thinking there is that with their 2 drogue chutes, if one of them fails, the other one will still work. So that would make sense to me. They got a redundant drogue chute, and then we also have we have a redundant final what would you call that, main parachutes. And then so apparently it slows you down to about 15 or 20 miles per hour, and then you splash down. So apparently when they splash down, they get a little bit of a jolt up to about around 2 Gs, which isn't too bad. And if you think about it, you're splashing into water, right? So it's not like you're landing on ground. I think the Russians used to land on just on the ground, but the Russians, they're pretty tough. And yeah, so there you go. You got the you splash it down there, and then it looks like this. So that's all nice and burnt up and everything when they take it out of the water. And there you go. There's your Crew Dragon all back in one piece, and everybody's all nice and safe and sound. And that's the way that works. Oh, the other thing, just for fun, I was wondering about the heat shield on it. So you can see at the very bottom there, it's sitting on. Let's see now, what do we got? Maybe not. That's not the best one. Let's take a look here. Let me see the heat shield. Okay. Well, anyways, at the bottom is a heat shield, and it almost looks like there's some kind of flotation thing there, but I guess not. So, anyways, the heat shield's on the bottom of this thing, and what is it? It's, and I was wondering how it worked. Like, you about the space shuttle had little tiles, and I always remember as a kid or whatever, the space shuttle goes up, when it comes back, it's losing tiles all over the place. But its heat shield is made of a material called pica, PICA, which is phenolic impregnated carbon ablator, something like that. And so what that is, it's like a lightweight ablative material. So, and it says, what does ablative mean? Well, it's let's get the whiteboard out again, just for fun. So this is my interpretation, my interpretive dance of how this is how the heat shield works. So you got the heat shield on the bottom of the your dragon, Crew Dragon. Okay, that looks weird. Okay, okay, this is not to scale. Okay, that looks really bad. Okay, I gotta draw a better crew capsule here. Hang tight. Okay, we got that. Wow, there we go. That's a weird looking egg, but I'm pretty sure it's the perfect capsule. So you got your heat shield here that's on the bottom. And so when that's coming into the earth, it's getting super, super hot. And this ablative material, so apparently it can be reused a few times. It gets really hot and creates kind of like a carbon. I guess it'd be like kind of like if you got like a barbecue and you got your little molecules on your charcoal, but it's kind of like that kind of white, crusty, fluffy, whatever. But you could scrape it off, and you got the hot coal there. You could scrape off more a bit later, and you still got the hot coal. So that's what, when it's coming into the atmosphere like this, these little guys kind of fall off, and with it, and they might even be kind of hot. So that dissipates some of the heat with the little bits that are coming off. So that's what they said there. It's some kind of weird resin, the carbon fiber resin thingamajig. But I mean, they've been working on that type of stuff from 50, 60 years ago. They were working on stuff like that. So it was it's very time tested and true, apparently. And SpaceX uses a version of that that's just a little bit different than the NASA version. So that's the idea. That's your Pika Pika. Pikachu, Pika Pika. And that is the stuff that the heat shield's made out of. I thought that was kind of interesting. But yeah. Okay, so that's cool. Splashes down. Let's get another picture here of our burnt up. Whoops. We get our burnt up capsule. Yeah, and it's kind of neat. That's it's amazing that atmosphere makes it that burnt, but it's very, very hot when it's coming in. Apparently it is 3,000 degrees Fahrenheit when it's coming in. So 3,000 Fahrenheit, that's pretty hot. think about the hottest your stove can get is about 500, right? So 6 times your stove, that is pretty hot. And that will melt, 3,000. Yeah, that'll melt aluminum. Will that melt steel? I don't know. But anyways, there we go. Well, that is it for, that's pretty much it for today's show. Let's get that out of there. Yep. Okay, cool. So there you go. Hope you learned something there about your, you got your Pika Pika that's on the bottom of the capsule, and then you also got the, not the hyperbolic, but the hypergolic engine, where it's just two things come together, they automatically ignite. You don't need a little ignition source in there. So I mean, that's pretty ingenious. I guess that's probably been around for a while, but that is very Elon Musk to simplify the process. And for anything in aviation, the less you got, the less chances something's going to break. So good thinking, Elon. Glad everybody got back from the space shuttle okay. And the space station. You can tell I'm a Gen Xer. And okay, so that's about it. What is today? Today's Wednesday. Okay, there we go. So I will be back on Friday, because I do this Monday, Wednesday, Friday at noon Eastern. And we'll just kind of shut her down. So yeah. Thanks for showing up in the chat, Daniel. And that's right, Monday, Wednesday, Friday at noon Eastern. And cool. Thanks for showing up, and thanks for watching. I guess we'll shut her down. Bye.